Okay, as of for today what I want to do is to go back and talk about the control flow of a MATLAB program. So looking at if, for, while constructs, if statements, and for and while loops. Then what I want to do is look into function definition, and at that point you will be pretty much on your own. You will be able to program comfortably in MATLAB. At the same time, we have on Thursday we said that maybe half of the time should be approximately on exercises. So I want to give you feedback on what you did. So there was a challenge, and we have a winner, so we have to look at that too. Okay, let's start. I don't know why this guy shut down. So let's start from the if statement that I briefly introduced last week, except that I had forgotten the syntax. That's a tiny little drawback. So now I studied the syntax. If statement, if you don't need the parentheses, if you put parentheses, it's nice. Then you put a test. Again, you don't need them. Then there is no then statement, so forget about that. But if you want to write everything in a single row, then you really need the comma. Then you can say c equals 3. Now, how to distinguish well, how to finish? Well, you really need a comma or a semicolon, even if that is your last statement. So this means if 3 is less than 5, please execute that assignment. Otherwise, okay, don't do anything. And if you put a semicolon, the same syntax, the instruction is executed, but the output is not displayed. And then we have else. If you want, we can add an else. Now we say c equals 5. This would not work because we need a final, a closing comma or semicolon before the end statement. Okay, so we have seen at the okay, this is just for syntactic sugar. If you want to go to new line, you can put the 3 dots and you go to a new line. Again, the comma is not necessary. And the most general way it's here, the most general statement is instead of having the else branch, you put the else if, and then you start over. Else if, another test, and another then, another else if you want. You can nest the else ifs and so on. So here we would say if 3 equals 5 and so on, and then here we can have here we can have else. Of course not. Well, okay, I should have added a colon here, a comma there, or a semicolon. Oops. Yes?
Do you know if MATLAB has cases?
Yes, MATLAB does have a case. It's called the switch. So for this thing, the help is actually your best friend. MATLAB does have a switch, and it's very much like a case. So you take a switch, you take one expression, one variable, whatever, and then you put a number of cases, statements, and then there is a final order otherwise. So if none of these cases goes through, if none of those conditions is met, this is the fallback statement, and this is always matched.
So we don't need breaks like in Java or C++?
No, that's right. Okay, so we have the if, we have the if else, the if else if, we have the switch. Let's go to for so that we can build some loops. fours are nice, what do you have to do? You have to pass a vector to the, well, you have to pass a vector after some index. So we say for I, and now we have to say which values I is allowed to take. So either we specify a vector ourselves or we build a vector, so we can pass a constructor. In the first case, we say, okay, I can be pi over 2 times pi. So here we are building the vector ourselves, and then we want to do something with this. We say I squared. And here we go. Or maybe we don't want to, we don't have the vector explicit, then we can build it, and we can say from I in steps of pi over 2 up to 10. And what do we do with it? 1 over I. Okay, and we print all of these things. We can use, of course, Linspace, if you remember. Help Linspace, it's linearly spaced vectors, so you give the bounds and how many points you want in between. So for I equal and then Linspace, this builds a vector, and then I scans the vector from left to right. Of course, you can scan from right to left, all of those nice things. We don't, I mean, it's just a for loop. Next, there is a while. And a while, no surprise, same story. You don't need the parentheses, you just need a condition, whatever it is. Then it's a comma and the body of the loop. In this particular case, it's 3 statements. It can be 1, it can be however many you want. And then there is always the end. So if, for, and while, they all have this end clause. Okay? Questions about the control flow? Okay, then let's go into something more interesting, unless I have an example to show you. 1 second. Yeah, let's go into something more interesting. The function definitions. At this point, I cannot really define a function here online. I go to my favorite editor. No, it's not my favorite. I go to the MATLAB's editor and I edit a function. So as I told you already, the name of the function has to coincide with the name of the file in which the function is stored. So how do we call this function? We call it stupid. Yes. Precisely.
Does that mean we can't have more than one function in one file?
Very good. You're running ahead. So this file, it's called stupid from now on. So the function definition associated with this file can only be stupid. Okay? That's the only function that will be accessible from MATLAB. The function stupid itself might need other functions, other sub-functions and other functions. And if you want, you can make them private, so you can make them accessible only to stupid by defining them in the same file after the main definition. Okay, how to define a function? We have to put the keyword function, and that has to be on the first row, or actually it has to be the first meaningful row. So I think there can be empty rows, I'm not sure. And then you have to specify the output. So here you define whether your function spits out one scalar, well, spits out nothing, or spits out 1, 2, 3 parameters, objects. So let's say that we want function to return a matrix, or whatever, this object. And we say equal. And then here is the name of the function. Again, you don't have any choice. It has to be stupid. But here you can say, you can specify the argument list. Of course, it could be empty if you don't want anything. Let's say that we take an integer. Notice there are no types. So if you come from almost any other language, forget about it. There are no types. It's all deduced dynamically. Okay, my function, if you want, you can have a beginning and an end, but you don't have to. If you want, it would be nice if the body of this function did something on m. Since eventually you want stupid to return m, it would be nice if you do some, if you did some computation, something like m equals I. Is it I or i's? I of n. Okay, and actually this is my function definition already. I don't need anything to finish it. It's better if you put an end. It's much better, but you don't need to. Okay, it works either way. And n is the input argument. You read n, you create I of n, so the identity matrix, you assigned it to m. Okay, that's it. The function at this point returns the object m. Of course, you can have multiple definitions, multiple assignments. And what this function returns is the value of m at the end of the body. So let's just see what happens. Stupid. This will not work. Okay. It complains because it wants an input argument. Let's pass an input argument, and now I get a random matrix. Not that. Where is it? Okay. Let's say now that I want my function to return more than one object. So I want it to return A and B. I have to concatenate the output with the square brackets. Remember I told you the square brackets only work if whatever they are concatenating makes sense in terms of a matrix size. Okay, this is an exception. This is not, you're not really building an object. Here you're just listing the output arguments. So these A and B could be completely unrelated with one another in terms of sizes. For instance, I can say that A is a random matrix and B equals n plus 1. Okay? If you did this back in our MATLAB window, this wouldn't work because I'm trying to concatenate whatever n by n object with a scalar. So those square brackets would fail, but here it's perfectly fine. Let's see what happens. Now if I call the stupid of 4, I will get my 4 by 4 matrix. So where's the trick here? I have to ask for more than one output. Now I'm extracting both outputs out of MATLAB. Okay, the first one is my 4 by 4 matrix. The second one is a scalar. No. Do you think this would work? 1 second. Do you think this would work? Yes. Yes, it will work. So you are allowed to overwrite the input arguments. N will be overwritten, and as a matter of fact, now my output matrix will not be n by n, but will be n plus 1 by n plus 1. So let's just look at it. Yes?
For integers, somewhat intuitive to be passed by value, but doesn't MATLAB also pass matrices by value if you pass a matrix to n?
So MATLAB passes, MATLAB copies everything. Whenever you pass an object, it actually creates a copy of it. So it's not.
So if I put a 1 million times 1 million matrix in a function call, it's not very good because I have.
Yeah. Did I say that MATLAB is for high performance? No, MATLAB is for prototyping. So you cannot do that in MATLAB, no. All right, one more example. Let's put a vector here. Let's put some other object. It's kind of a limit, but that makes everything simple. So, okay. Okay, what's the output now? I have I am trying to spit out 4 objects. It's a matrix. First is a matrix, the second is a scalar, the third is a vector, the fourth is undefined. Okay, over here I am accessing only the first 2, so I will access a matrix and a scalar. That's fine. Let's continue extracting objects. Now I get also a vector. Notice that n was 4, now it has become 5, so my vector is actually 5 by 1. And if I want to do more, here it is what happens. I'm trying to extract an object. The function, there is nothing wrong with it. The function returns 4 objects. The problem is that in the body of the function, I didn't do anything on D, and so everything breaks, everything goes wrong there. So now if I say that D is a string, okay, everything works. As I was saying before, if I want this function to use some local private functions, that's perfectly fine. I can define them down here. Over here I can put any number of functions that are only accessible by stupid. Okay? Questions about this? Yes?
So when we input, for example, 3 values in the function definition, and we call the program with 2 inputs.
Oh, that's not gonna work. Oops. Oh, really? No, please. I didn't know this.
P and K are not used, so
Sorry?
P and K are not used, so no harm done.
Yeah, I know. So there is no typing whatsoever. That's right.
What if I just want A and B, but I don't want the second output?
Yeah, I don't know if you can do that. I don't know if you can skip some of the, I'm not sure. Yeah. Anyway, if you guys want to try all of these, doc function, that's what to look at. As I said, help and docs are your resources, and here it explains pretty much everything I said. If you're really courageous, you might want to look for varg_in and varg_out, which, var_arg_in and var_arg_out, yes, which is a way of defining functions with a variable number of input arguments and a variable number of output arguments. But I leave this up to you. Okay, I think now you can define your functions. What I suggest you guys do, since now you have everything to play with MATLAB, is to look at a few exercises. This is not an assignment, it's just a suggestion for you. So we looked at the summation from 1 to some n. We saw that that is different from the summation n to 1. So I suggest you guys play with this. In particular, we know that this thing, so the limit of the summation would be, or something like that. And I showed you already that this thing here really does not go to pi squared over 6, while this thing seemed to converge slowly, but it seemed to actually converge. I think I showed you that for a certain n, once you pass a certain n, there is no difference here. So let's say that there is an n bar. Let's call this thing, let's call it a function, f of n. It's defined like that. So I showed you that there is a certain f bar such that if n1 and n2 are larger than n bar, then f of n1 equals f of n2. What does it mean? It means that even if you add more terms, nothing is going to change. We could even make it simpler. There is an n bar such that f of n1 equals f of n bar. So we can simplify that. Means that there is a point after which it doesn't matter if you add more terms, this function will, the output is not going to change. So maybe you could write a code, a little program that finds this n bar. I think I even told you what the value of n bar is. And yeah, okay. That's a possibility. Another possibility is we talked about floating point numbers. We talked about these epsilon or u, the machine precision. We have a number of different definitions. Maybe you could take one of those or two of those definitions and write a program to compute epsilon. For instance, one of the definitions was it's the largest u such that that is still equal to 1, or it's the smallest such that, right? So you could write programs that determine the u, but this seems a mu, it's an actually it's a u. These are just suggestions for you guys. Or you can write a program to find the smallest floating point number. So we had the 0 here. Then we had the first normalized number. And then I told you that over here there is a big gap with a bunch of unnormalized numbers. So maybe you want to find the smallest floating point number. Again, you write a very simple loop, probably, to identify this thing. Okay. Yeah. I think what we can do as an example, and then I'm done with MATLAB, at least with the programming, is to show how to mimic our assignment. So edit as, no, where am I? Okay, edit assignment. All right, first of all, we add an input, oops, we add an input matrix A, so we have to create that. Let's say that A is a random matrix 4 by 4 or 8 by 8, it doesn't matter. And then we add to partition the matrix across among 4 different processors. Okay, so maybe we should say, let's assume that this 4 is actually an input parameter. Now we want to find the breakpoints to split the matrix among 4 processors. So we can say n2, which would be n over 2. Actually, 1 second. Okay, so I'm assuming that this 4 comes from some external parameter, so maybe we don't know what it is. Here I extract n and m that are going to be 4 and 4. And here I define the cutting points. So this would be n divided by 2 floor in case we are in case we find odd numbers. This is the same. Okay, and now I have everything. I can start dividing the matrix. I'm gonna say A top left equals A. We know how to extract a portion of a matrix in MATLAB. It's actually easy with the column statement, the column notation. So I can say ta. Okay, this is the top left quadrant. In fact, it's the top left quarter of the matrix A. Processor P2 was operating here on the right, so why don't I just define my A top right where it belongs, right here. And now we have M2 plus 1 up to end. Okay. And 2 plus 1 end, but I like, what is it? That's the, okay, I like alignment, so I'm gonna do this. And over here, I will not have enough room. There. Okay, so I have created my 2x2 object, so I'm ready to perform some communication, which I don't have in MATLAB, so okay, I will have to do. This is processor 0. What does it do? It sends A top left to processor 1, whatever, there is a tag. Okay, let's go up here. Oh, I'm processor 1 here. And what do? I receive something. Why is it stuck? Okay. And I receive something from processor 0. After that, I receive something. And this guy instead sends something. Okay, now it's time to do some computation. So I'm processor 0. I like to do a top left equals, or maybe plus equal, that's okay. A top left plus a top right. Instead, I am processor 1. I would like to do a top right equals a top left minus a top right. Okay, then we could do the same with the other processors. P1, P2, and P3. And you see that the assignment took all of what? 2 minutes? Nope. Bottom left, bottom right. Okay, and now let's just finish the game here. Let's say that now I want to form the final matrix. Oh, wait, these are not A's, these are, yeah, okay, these are the, so let's say that now I want to form the matrix B that puts everything together. Well, I have the square brackets, that's what they're good for. So I can put this thing together. Let's see if anybody catches the problem. And you see how I like to actually align these things because I am putting together 4 quadrants. I see people worrying about something. Yeah, what's the problem? I like this comment. People are saying there should be a semicolon because I'm going to the next line. Yes, that's a very good point. There should also be a dot, dot, dot because I'm splitting one operation among 2 lines. Okay, let's see if this works. Assignment. B equals, no, not B equals, it's not a function, sorry. So let's remove that. And here we go. Clearly, we don't appreciate what is going on, but we could, for instance, do the following. We could plot these things separately. And then we see that I am actually forming my B by piecing them together. Or, well, okay. Anyway, you get an idea. And I think that this is a pretty neat piece of code. So just to give a hint towards who's going to win this challenge. Do you guys have questions? No questions. If there are no questions, then I think I should go and talk about these guys. So I have selected these 4 guys as for different reasons, but not here, but forgot is attachment. So maybe you should let him know that it's more convenient for him if he attaches what he does, otherwise. All right, that was one. Then I selected these 3 guys because, truth to be told, there was no clear winner. These 3 guys I liked a lot, but it was a tough competition. So I want to start from, I think it's our filmmaker here. Right? That's you, right? Okay, this is brilliant. This is absolutely awesome. But you didn't have the balls to actually write a program like that. So had you put the statements instead of the arrows, so had you actually written the code in these four quadrants, this would be a clear winner. That's exactly what's happening. And look how beautiful it is. Everything converges towards the center. That's the output. I think it's brilliant. But he chickened out and he ended up doing a parametric program. So this would have been a winner, but it's not, because this is not a program. Okay, I liked Jopic. I like this a lot too. He went nuts with this presentation. I don't really care about this part, but you know, he split the program in different pages. So this is like phase one, which is true. That's exactly how the computation proceeds. We compute B first, and then we move on and we compute C. The problem is, so in the first stage, the communication works horizontally. The second stage, the communication happens vertically. So this is brilliant. It's super cool. But, gosh, seriously, double loop. Oh, my God. Double loop. It's brutal. It really killed me. And also, what's up with the alignment, with the indentation? I mean, from 4 to 4, you indent by 8 characters, maybe. So that's fine. Then I expect this guy to be 8 characters in, right? So, you are so close, but not quite. Didn't work. Then you got already the idea that the winner is Buchwald? Buchwald. Is it you? Okay, congratulations. Simplicity won. So that's the winning program. It's really simple. And you know, it works. Well, actually, he came up with this rename because he wanted to be fancy, and we don't care. You were free to use your own language. So that's what I liked. There is a send, a receive, there is some communication. You know clearly who is computing on what. The output is there, okay, everything is fine. The final sync is missing. Unfortunately, I don't think anyone actually got the program down with all the syncs in the perfect spots. Now, don't think that I didn't catch that you made a mistake here. I did catch it. This get, the assignment is missing. Normally here there should be something equals get. But that's how he used this rename. He's actually assigning to this variable. This is the same as BL equals get of BL. So, okay, that's fine. And then he comes here and BL changes name to the variable, now becomes TR. So this is a TR equals get of TR. So it's fine. I would have been happier with a sync at the end. Some of you put the sync in the end. I loved it. Some of you put the sync at the beginning. Some of you put way too many syncs. Okay, I also some other names that I enjoyed. Pubst, not here? Oh, here. Yes, I enjoyed yours too, but there were problems. I think your complete was doing something. Oh, okay. And several of you guys used the complete to check whether other processors were completing. Yeah?
So maybe one question. Why is the program using now temporary matrices?
It's the program doing what?
Why does the program don't use any temporary matrices?
It does. It's all hidden in this rename. So BL is a temporary matrix. It's not as local. It took me a while. So that's why this was not a clear winner. I showed you what could have won, but this is the best of what we got. Stengele? Yeah, I loved yours too, but I don't, wait, Stengle? I don't want to look at it. Okay, but I liked yours too, as well as Farshad or Farsad. It was you? Yes, I liked your too. Then we had a winner for the shortest, which is Shemmel. Not here. It was literally 2 lines of code. Totally unreadable, but very, very short. Okay, so since this is done, maybe I can take the opportunity to show you, to discuss a little bit more about this. The objective here was elegance, was to create something that, while minimizing the number of things, would speak for itself, okay? Clearly, when you write codes, you might have different objectives. So let's see how the code changes is affected if we change these objectives. Ah, they broke it. Okay. Guess I'm not going to use it. So I set the rules, and let's see if you guys come up with a solution. In the original problem, each processor had 2 times n over 2 times n over 2 local space, workspace, okay? One of these n by 2 times n by 2 was taken by the local matrix, and the other one was auxiliary. What if I want to minimize that? So now I want to minimize the workspace. That's the objective. Clearly, n over 2 times n over 2, we need that because we have our local. And then we want something that is small. Yes?
The ultimate minimize would be 1. So we just get one value and add it to the one place it has to be added to.
That's your opinion. Did you have another one? Yeah? So what would the program look like if we have this?
Synchronous or asynchronous?
It's, let's say, asynchronous, of course. Yes. So now we have a very little workspace. First of all, I'm not even sure if this is enough. That is a suggestion. If you guys can argue that you need more. Yeah?
So we have to iterate over, so if we want to first do the horizontal communication, we need to iterate over both matrices.
Okay. So you exchange this first object. Okay. And we iterate like how?
Depends on how, no, it doesn't matter really. It definitely will be in that workspace.
Mm-hmm. Okay. Yeah?
So you would have, the problem is when you get the value and you add it to the design place, you change the value of the design place. So other processes can't get the value, the first value in this place.
That.
So actually you have to sync after every get.
That's right, yeah. Or after every compute, because you don't have to write over here, you could write in your auxiliary, right? So whatever this entry here could be stored in your auxiliary. Then the next entry could be stored here, then the next entry, and so on. Yeah? But you need a sync for every step, for sure. Yeah?
I think it's more elegant if we don't use the matrix, but store it in the auxiliary, do the computation in the auxiliary, sync, write it back to the matrix, and then use the auxiliary again, so
Yeah.
we don't have to shift the matrix at the end.
Yeah, that's a good point. Yeah. I like that too. Some of you guys did this actually. I think the almost winner has as many sinks as entries in the submatrix. So n over 2 times n over 2 sinks. So for each entry there is a sink. Am I correct? Okay. Somebody sinks for, because you guys have this killer double loop, this horrible object. But moral of the story is that depending on what you want to do, you have to resort to a double loop. In this particular case, somebody didn't resort in a double loop. Somebody said, this is a local matrix. So ultimately, it's a long piece of memory. I can just go with one single loop. That's also valid. It's one step better than a double loop. Yeah. Okay, so if you want to minimize the workspace, this is actually the minimum you can do. Assuming that all the programs are doing the same. You could do even better, but then you break the symmetry. Let's change the rules. What if I really want to minimize?
Oh, wait. So with one, that's correct?
Yeah, it is correct.
You have to remember, when you compute the value, you get rid of the old value and you need it in P1.
That's why you need to sync. You can only overwrite this once you are sure that P1 has read it. So I can.
So every process has +1.
Yes, for sure. All of this is by process. Yeah. Okay. Now let's minimize the computation time. Execution time. And before going there, let me show you how to look at these things in parallel. Now we have time is going downwards. So this is time. And this is what happens on these two processors. Processor 0 at the beginning does nothing, it sends some data. So it issues a send. But actually it has to wait because the send doesn't go through until P1 issues a receive. The receive might be before, might be after. You cannot assume that these guys start at the same time. So there will be some wait until P1 issues a receive. This is all time wasted. So let's say that the computation starts there. We go with a tick. I forgot. In MATLAB, how to measure time, you write tick, then you put some computation, and then at some point you write talk, and that has taken the time. I'll show you in a minute. Okay, so processor 0 has issued a send, but nothing happens because there is no receive. Finally, the receive is issued, so the data actually moves. And the data movement takes time. So even though the receive starts here, then there is some extra wait due to the data to actually move from one processor to another. Okay, at this point, we know that A top left has reached processor 1. Still no computation. At this point, is issues probably here. a receive. This guy goes immediately with a send. So now it's just the time to go back. And at this point, the two guys, more or less, these need not be same exact time. So maybe this starts here, this guy starts there, and now they compute. This is finally some computation. This is A top left plus A top right. And here, we cannot assume that they compute at the same rate. Here is A top left minus A top right. Okay? At that point, there is more computation, more communication, not with P1. This guy now wants to communicate with P2, so he will issue a send, but he has to wait until P2 issues a received. Maybe P2 was done and issued received very early on. Then the send starts immediately. Okay, this guy was here waiting. At the end of the day, what am I showing? There will be a point when C is computed. That's when you call talk. And you have to look at how much work the processors have actually done and how long they have been waiting on these sends and receives. So these processors were idle, were doing no useful operations. And all of these, and so from here there will be this computation. This is the space that you want to reduce. That's the time that you want to minimize. Why I'm not asking you guys to minimize the compute time? There is nothing you can do about that. There is the amount of data you have to process is fixed. I'm not saying that you have to optimize the code or anything, so nothing to do for the computation. But maybe you can do something to minimize the communication, and you certainly can do something. So now our objective is minimizing the execution time. How? By minimizing the communication time. So ideas. Yes, of course.
What about the workspace? Is it fixed or can you
Oh, that's right. Let's go back to our full workspace.
so we cannot even make it larger? Like 3?
No, that's enough. Somebody asked me something along those lines. Actually, I think it's the guy that normally sits here, but today is not here. Okay.
Could you begin the calculation as the data is coming in?
Aha, that's a very good idea. How would you do that?
If you were to mark the original data space, for instance, with flag values.
Whoa, that's a dangerous idea. How to do it a little bit more elegantly? I think you're spot on, but let's see how to do that. Yeah?
We can compute while the data is coming in.
Why not?
Okay, then we are using asynchronous.
Yeah, as I said, the
Okay.
yes.
Okay, we can just get from the other processor.
Mm-hmm.
P1 get from P0, P0 from P1.
1 second, let's say auxiliary, we get something from P0 and not from P1. Okay, this guy does something similar. Okay.
Yeah, then we complete. We can complete on the other guy's get. So we have to
sync.
So let's say T. Okay, you want to complete on T?
I want to complete on T and on the other guy.
No, that's an improper use of complete.
Yeah, so I have to sync.
So you want to complete or sync?
I have to sync. Because I can't complete on foreign processors.
But if you sync here, what are you syncing on? That's,
On all processors.
yeah, but what's the advantage? You don't know, I mean, this doesn't buy you anything.
There's no point in syncing on diskette.
Yeah.
Because I could just use the blocking API. And I can't sync on whatever processor 1 is doing.
No, exactly.
So completion is useless. I have to sync. Yes.
What were you trying to say?
Well, as we got asynchronous possibilities, it might be easier to yeah, just get it complete, and then you can already go on with the next matrix after sync.
Hmm?
We could not not try to get the whole matrix at once.
Ah,
Let's start maybe like line-wise because
that's a good
one
idea.
element-wise.
Let's restrict ourselves to something smaller so that we at least we can. Sorry?
But then we would have a double folder or
That's
a
o-
single folder.
That's okay. That's what I'm saying. You have to adjust your program to the demands. So maybe we can take not the whole matrix, but just a portion of it. So let's say that I fetch this part. So I don't want A top right the whole thing, but just a part of it. Let's say A top right 0, which would be this column. A top right 0. Then the next column would be A top right 1. And then A top right 2, and so on. Okay. Now I complete, but I complete only T0. Okay, that's fine. 1 second. But maybe I should do something else. Yeah? Yeah, you were trying to say something?
I just wondered whether if we were going through all the columns,
Yes?
we would have to complete for all columns, or wait for the complete of all columns, or of each column to do the operation on it.
Yeah, notice that now my tag is T0.
Yeah, but then you somehow have to determine whether it's already done, so you have to go column-wise again, and I doubt it's faster than if you just fetch the whole thing.
Other people wanted to say something, yeah?
We could first start getting everything, so we do a follow-up and try to get every column.
Yes.
Then we wait for the first column to complete.
Yes. So let's postpone this complete here. And let's say aux1 equals get A top right 1, P1, T1. Okay, now I'm actually moving 2 pieces, or at least I'm asking for 2 pieces to be moved at the same time. Now I can either issue, yeah?
Well, so I assume we are not multi-threading. So we have one processor and he can do one instruction one time. Okay, we have 4 processors, but
Wait.
one processor can only do one instruction at one time. So it can either get aux0 or aux1.
So wait a second. First of all, this is important. In a real world, these operations are not performed by the processor. These operations are performed by a coprocessor, by a bus, by the network. This is not, the processor maybe only intervenes to synchronize these things. And it's in our buses, I didn't say it, so it's a valid argument. But nowadays in our bus, you can do 2, 4 reads at a time, no problem. If you go on the cell processor, you can do 128 or 256 at a time. But it's a good point. But this is not multi-threading, okay? Yeah?
How about bandwidth?
How about what?
Bandwidth.
Bandwidth? Oh, bandwidth. Yeah, of course. That's all part of the story, absolutely. Let me finish the algorithm and then we can discuss these things. You wanted to say something?
I was going to say that the original functions didn't allow us to specify length, so does that mean we need to introduce a whole array of new variables just to
Yeah.
achieve this?
Precisely, that's what some people did. They accessed the matrix entry by entry, or somebody accessed it actually row by row. So yeah, sure. You have to write a for loop that does this for you. Yeah. Okay, at this point we could either issue the get for all the columns, or maybe start an iterative process. What do we do? We're just happy with this, and we say complete T0. Okay. The moment T0 completes means that now I know for sure there is only one communication happening, so I can issue another one right away. Get a top right 2 P2 T2. Okay, why? Because this goes in the background. This one tells me that A0 is done. Wow, you guys are really angry already. What's going on?
So assuming we have unlimited bandwidth, we could just say aux0 to aux9 and...
As I said, these are two different options. Either you issue all the gets at once, or you go a little by little. In reality, the bandwidth is not infinite, so what you want to do is to play with this, but as long as it's convenient for you. Yeah?
Well, it depends whether we assume that these both operations are done in parallel, or maybe there's just one queue where all these get requests
Yeah.
are entered and it
So in real life, you cannot say anything about this. All of this is done
it depends.
in the background. You cannot control these things.
I still don't understand why getting column by column from this matrix will be faster than getting the whole matrix.
Yeah. So it's not, the trick is not column by column. That's just an example.
Yeah, but row by row.
We could go
Little part.
little by little part, because as soon as this guy makes it to my local memory, I can start computing. The assumption is that transferring a little piece takes less than transferring the whole thing.
We just didn't try the computation.
Yeah, I couldn't make it because I had angry people to calm.
I just thought that you will write all gets, all completes. And
No. Now this is the interesting part. Now we can finally start saying auxiliary 0 equals a top left 0. So my local column plus what I got from the other guy, which is auxiliary 0. This computation here, let's see when it starts. I didn't have to wait for the whole fetch. Okay, never mind that this is the asynchronous one, and there it's asynchronous. Moral of the story is that I can start computing earlier on. So I have reduced the initial delay. So I do my computation. Then what do I have to do? Do I have to sync? Anyone for a sync?
Yes, because another processor will get this. No, we don't need, because we write in aux.
Yes, we don't need it, because we can still use our auxiliary. In fact, we don't even need so much auxiliary. We need just as much as the number of transfers. So we can use our auxiliary to our auxiliary 1. We can overwrite that. So what we need to do now is complete T1. 1 second, you guys. If T1 is completed, I know that A0 is done, A1 is done, A2 is the only communication that is working, so I can get another part. AUX 3. Get A top right 3, and so on. Okay, what's the complaint?
I wrote for a is complete function because you can't be sure that T0 completes before T1.
No, you cannot be sure, that's right.
So,
So you vote for what?
is complete function that
Sure, the best of the two. Yeah. The complaint is absolutely fair. We issued these two gets. For no reason, get 0, so complete of T0, will happen before complete of T1. We cannot assume that. So I'm just enforcing this order. Possibly I'm wasting time there, but that's okay. Such is life. Did you guys get this? And you see that depending on different objectives, the code changes dramatically. In this case, the for loop is perfectly fine. But now I have minimized the execution time. Why have I minimized the execution time? Because all of these gets, let's see, this get, and all the following gets are performed while the processor is doing something. So the communication is overlapped, is happening actually during this phase here. Okay? That's why if you put everything together, maybe I should show it. Since we have time, I think. Yes. Okay, let's see what it's like. P0, P1. Get A top left. A top left is a big matrix, so this get takes a long time. And what it means is that I'm going here and I'm fetching data. Okay. Let's go to P0 hat. That's the smart version of bar. P0 bar, that's the smart version. Now I only get A top left 0. Okay, and this get takes less time. So I can start computing right here. But I don't compute and then issue another get. That would be stupid. I issue immediately a get for A top left 1. So this get now happens while this computation is happening. So there is an overlap of communication and computation. The program looks nastier, but the end result is faster. Yeah?
I've got a question. Would it be better to just calculate B first, then sim, and then calculate C ongoing from B? Or would it be faster to just fetch A top left, A top right, A bottom right independently without calculating B first? You would have 3 times some transfer operation.
So if I understand, you're breaking the symmetry, you're saying only P0 does everything?
No.
And fetches?
P0 fetches from P1 to P2, P3.
Yeah.
And P1 fetches from P0, P2 to P3 and so on.
Whoa.
That's
Why would the P0 fetch from P2?
You just skip
Peter.
Typically, you just don't calculate copy.
Yeah.
Oh, I see. Why would that be faster? Now you're doing. Now you're doing. What I showed, it's a logarithmic algorithm. So you have, for instance, you have 4 objects, and you add them in pairs. So you have a logarithm number of steps. What you have, it's a linear number of steps, because you have to add each one separately.
But maybe communication between two processes might be. It's been just an idea.
No, I'm telling you. I don't want to focus too much on this, but if we talk about performance, communication is super slow. When we go to MPI, this kind of communication, one data transfer is as fast, takes as long as at least 1,000 of operations performed locally. So it's out of discussion. All right? Other questions? Nothing. Good. TikTok. We want to, well, let's just go for an example. So n equals 500. Start equals tick. Oh no. Yep. Ig. What? What was the problem? Oh, sorry. Okay, 1 second, 40. Now we go to oh, it's not symmetric. I see. So I'm creating a random symmetric matrix. Okay, let's see if I can embarrass myself now. This should take a minute. So Ig is a function that is cubic in the size of the input matrix. So I have started with a matrix of size 500, and that's the time, 0.77. Then I doubled the input size. Since the function is cubic, doubling the input size means 8 times as much time. And so that was more or less, it was around maybe 9 times. So now I doubled again, and I should get a result in about 56 seconds, so in about a minute. Let's see, I've been talking for 30 seconds already. So you know how to use tick and talk. Well, okay, that's a pretty good, huh? 56 seconds versus 55. Okay, just to finish the lecture today, I wanted to tell you how to print and maybe read some data. That's kind of useful. There is the input statement that lets you write something, actually type something, and you type it, and now my C has been assigned to that. There is even a way to, there is a variant of the input command to read the clicks of your mouse. So it reads the coordinate of the clicks. I don't know if that is useful for anything, but okay, how to print something. So how to display what we did. I told you that this suppresses, semicolon suppresses the output, so whenever you want to see something, even inside of your program, you just have not to put a semicolon. So I remove that. It's in the middle of a program, but it's perfectly fine. If I execute that, now I will have a bottom right explicitly shown. Assignment, and you see in the middle of the program I have the printout of a bottom right. Then you can use display. I think you've seen it already. And together with display, there is also Disp. Display actually can be a little bit annoying. Because, I mean, it's nice because you can typeset something. But it's annoying because, oh yeah, good luck. All right, forget about that. It's annoying because it always spits out the actual name of the variable. If you just want to plot something, then Disp does a better job. If you want to format something like what I was trying to do here above, the way to go is with fprintf. And I will explain printf and fprintf in C. For MATLAB, I say, why don't you do this? There is a little misleading piece of information. It says write formatted data to file. Well, it's not entirely true. If you omit the first argument, it just prints to screen. Okay? Maybe I can give you one example. So now we want F. Okay, very, very briefly, this thing here tells MATLAB how to plot the information that comes here. 6 means takes 6 spaces. 3 means uses 3 digits. F means whatever comes next is a floating point number. So now I'm plotting pi with the 3 digits. God knows why I get 4, but thank you. If that is true, then now I'm going to get 5. Yes, thanks. I didn't know that. Okay, now if you want to go to file, so more useful operations, now you have fprintf again, but at this point you have to specify the file to which you write. That has to be the first parameter, the first argument. Then you need to open a file. That's why there is fopen. And then in the end, you would close the file. There is fclose. If you want to read from a file, there are a number of different ways. fscanf is to, well, it's the corresponding of fprintf. And then there are commands to generate binary files. You know that you can compress data by not storing it in textual form, but into binary form. And so there is f read and f write to do that. So this thing creates files that you cannot access just by looking at it. It's not text files anymore. For a complete description of all of these things, you should look at IOFun, input-output functions. And there is a lot of documentation here. But as I said, the important ones are fread and fwrite for binary files, and then fprintf and fscanf. Okay. I think I am done for today.
I have a question.
Yes.
If you print one time y, could you write y?
Yes. So this is a joke. Normally there are not normally. So there are a number of people in this, and these are normally people well known in either the computing community or in the numerical linear algebra community. So I know some of these names. It's a joke. These I've never looked at. Ah, I see. Okay, guys, I'll see you next Tuesday.